respiratory volume per minute, surface air consumption rate, minimum reserve. The variation in consumption with the depth is due to the fact that with a constant respiratory rhythm, we breathe different densities of gas depending on the depth. The constant factor, if physical activity remains the same, is the volume of air breathed in 1 minute, which has been defined as the respiratory minute volume, RMV. A diver with a respiratory minute volume of 20 litres a minute, quarts a minute, breathes 20 litres of air in 1 minute, quarts a minute, whatever the pressure. It is the normal litres that change. The respiratory minute volume is not always constant, but varies with activity. It can fall by half if the diver stops and more than triple with physical exertion. To calculate the respiratory minute volume, just multiply surface air consumption rate in bar a minute, the surface air consumption rate in pounds per square inch a minute divided by 15 by the cylinder capacity. If with a cylinder with a capacity of 15 litres, quarts, you have a surface air consumption rate of 2 bars a minute, 30 divided by 15 pounds per square inch a minute equals 2. The respiratory minute volume is 30, 2 multiplied by 15 litres a minute, quarts a minute. The surface air consumption varies depending on the cylinder being used. This is because only the respiratory minute volume remains constant. To calculate the new surface air consumption using the metric system, just use the formula surface air consumption equals respiratory minute volume divided by cylinder capacity. With a respiratory minute volume of 30 litres a minute, using a cylinder with a capacity of 15 litres, we have a surface air consumption equal to 2 bars a minute, 30 divided by 15. Instead, with a cylinder of 10 litres, the surface air consumption becomes 3 bars a minute, 30 divided by 10. With the imperial system, you must use the tank factor that enables you to pass from surface air consumption to respiratory minute volume in cubic feet a minute. This is equal to the ratio between the volume of the cylinder and the pressure at which it is measured. For example, in a steel cylinder of 96 cubic feet at 3,300 pounds per square inch, it is 0.02909, 96 divided by 3,300. So the surface air consumption of 90 pounds per square inch a minute can be converted into a consumption of 2.62 cubic feet a minute. This is a constant figure on the surface, linked to the respiratory volume minute. Changing to an aluminium cylinder of 80 cubic feet at 3,000 pounds per square inch, the new tank factor is 0.02667, 80 divided by 3,000. To calculate the new surface air consumption, divide the consumption in cubic feet a minute by this factor. The result for the example is 113. 2.62 divided by 0.02667 pounds per square inch a minute. Now the surface air consumption is known, it is easy to calculate the minimum reserve. Just multiply the surface air consumption by the absolute pressure and then calculate the number of bar needed to stay there for 10 minutes.